Even if the results the reporter referred to were the results of the impact observation, how would this conflict with the so-called teaser? Later in his video, Webb brings our attention to the lunar mineral Hapkeite. Discovery of this mineral was first announced at the 33rd Lunar and Planetary Science Conference in 2002. But the full details of such results were first made available to the public in the May 4, 2004 proceedings of the National Academy of Sciences. This was a good 2 years after the initial discovery of Hapkeite. Whichever way you cut the cake, Webb's logic makes no sense.
This second statement conflicts with the teaser and seems to be more consistent with reality, since ESA didn't release anything about the crash and the independent observations of the scattered dust before September 7, 2006. And since then, the only thing that ESA has published that mentions any minerals found on the moon are a few articles about the ill-fated Chandran-1. So why did the ABC announcer say that new minerals, plural, had already been identified in the dust and debris thrown up by SMART-1?
Probably because the ABC reporter was at the Mount Pleasant Observatory detecting the minerals in the first place. If you witness a car crash firsthand, you don't have to wait until the police issue a report to know about it.
This teaser appears to be bits and pieces of information taken from different sources available to ABC at the time. An article published by ABC Online just hours before the crash talks about plans to analyze the chemical signatures found in the flash of light from the impact.
I'd like to pause this to take the time to read this article.
The European Space Agency will be relying on a radio telescope in Tasmania to help it monitor the crash landing of one of its space probes on the moon. Tasmanian scientists will take a great leap towards discovering what the moon is made of with the monitoring of the crash landing. The SMART-1 probe has been sending back pictures of the moon since it was launched by the European Space Agency 3 years ago. This afternoon it will crash into the surface of the moon. Astrophysicist Jamie Stevens from the University of Tasmania will monitor the impact from a radio telescope just outside Hobart and says the exercise should yield vital information about the moon's composition. If you take a large optical telescope and look at the light coming from it, chemical signatures can be found, and this will tell us exactly what it's made of, he said.
Now why would Webb allege that the reporter could not possibly have known about new minerals when he read this article that clearly indicates the reporter would have had front row seats to the action and therefore would have known before anyone else?
The day after the crash, ABC published an article saying that they still hoped that the dust kicked up by the impact would tell them more about the moon. Why would they say that if the results were already in?
And the quote mining continues. The passage Webb points out simply reads,
Scientists hope that dust kicked up by the impact of the European Space Agency probe will tell them more about the moon's origin.
The operative phrase here is moon's origin. All this passage means is that the theories for the moon's origin will need to be pitched against the SMART-1 data and then see if those theories still stand up against this newly discovered information.
Battle 1. Fight!
This passage is essentially a verbatim echo of what Stevens said.
So each theory of moon's formation has a prediction for what the moon should be made out of, and by looking at what the moon is actually made of, we can eliminate some theories and reinforce others.
Webb doesn't even try to address the argument, but instead tries to poison the well by libeling the ABC and claiming the reporter made it up as a teaser. I mean, at least other propagandists who have posted on this video have at least attempted to provide an excuse for this. Destin325 wrote, "Rewatching the video, I also noticed something. At 6:18, listen carefully. By punching a 10-meter hole, the probe has uncovered minerals different to those gathered on the surface. To me that sounds more like a deliberate act to purposely bust a hole in order to reach further down than previously done. This explanation seems doubtful. According to the ABC article that Webb shows, the hole SMART-1 carved out was only 1 meter deep."
Incidentally, this article also mentions the 3 to 10 meter wide, 1 meter deep hole that SMART-1 would carve out in the lunar surface.
Go in. Oh, you're doing real good there, Charlie.
It's the most frustrating job.
Apollo astronauts allegedly took drilling equipment to the moon and collected core samples from that depth. The core samples had the same composition as the surface rocks. YouTube user Hapkeite had this to say along these lines. "This is so pathetically stupid, it's hardly worth the effort of refuting. Do you really think, JW, that samples taken near the surface, how far do you suppose the astronauts could dig? Half a meter? Or to match the rocks 10 meters below the surface? Suspicion would be justified if the rocks did match." I think he's a little confused as to the depth of the crater. It was 10 meters wide and 1 meter deep. Still, Gone2 Platt added, "Surface material, soil or moon dust samples should indeed be similar, but at the same time should be different from material a few to several meters down. Keep in mind that 4 billion years of micrometeoroid impacts have contaminated the surface soil with the mineral signatures of the micrometeorites themselves. Micrometeoroid impacts also create new minerals. Like Hapkeite says, suspicion would be justified if the composition of the surface soil also matched material from several meters down. In that case, let's make a comparison. For this demonstration, we'll examine the deep drill core sample from Apollo 16. This drill allegedly collected soil from as deep as 2 meters, twice the depth that SMART-1 penetrated. For comparison purposes, this tube was divided up into 6 separate samples. Sample 60007 corresponds to depths between 0 and 20 centimeters under the surface. Sample 60005 covers 60 to 105 centimeters deep. This is around the same range the SMART-1 penetrated. A quick look at their chemical compositions reveals that aside from a slight increase in titanium and iron, there appears to be no big difference between the samples collected above ground and below ground. Likewise, the mineralogy of the Apollo 16 core sample is about the same the whole way down. According to papers presented at the 7th Lunar Science Conference, the deep drill sample for Apollo 16 is mostly plagioclase. Sample 60007 is generally 45% to 80% plagioclase. The other minerals are mainly olivine, pyroxene, or glass, which tends to be around 5 to 20% by weight. The rest are tiny portions of opaque minerals, which typically refer to ilmenite. If we check the samples retrieved from deeper depths, we find that these ranges of plagioclase, olivine, pyroxene, glass, and ilmenite are not that different to the uppermost portion of the drill sample. If the composition of the underground lunar material is supposed to be different from the surface material, why is the Apollo 16 core sample virtually identical to its big brother up above? In fact, given that the rock the astronauts supposedly collected 2 meters below ground was the same as what they supposedly collected from the surface, we should expect the dust kicked up from only 1 meter below the ground to be the same. And yet, the Mount Pleasant Observatory detected different minerals. Returning to Webb's video on this subject, Webb goes on to allege that different minerals were not found by SMART-1, but found in a lunar meteorite.
The article also has a link to an April 27, 2004 article about a new lunar mineral, dubbed Hapkeite, found in a lunar meteorite that fell to Earth in Oman. This is the article that Jarrah should have used if he wanted to build a case for new minerals of lunar origin being discovered that were not already found in the Apollo moon rocks. Of course, how would the scientists know they were looking at a lunar meteorite if they didn't have the Apollo samples to compare to?
I was first made aware of this meteorite on September 2nd, 2009, when Stalker Vision sent me a link to a BBC article about it. In this article, there is something that I find quite interesting. Thank you, Webb, for giving me the opportunity to finally talk about it. The article reads,
Scientists say a new lunar mineral has been found in a meteorite from the moon that crashed to Earth in 2000. The mineral is called Hapkeite, after the scientist Bruce Hapkeite, who predicted the existence of the iron and silicon compounds on the moon 30 years ago. Hapkeite is probably made when tiny particles impact the moon at very high speeds, say Mahesh Anand and colleagues. Their investigation of meteorite Dhofar 280 is reported in the Proceedings of the National Academy of Sciences. Although hapkeite was first predicted to exist some 30 years ago, this is the first time it has been seen. Scientists think it could be a common ingredient of the lunar surface.
Firstly, there are actually 3 types of iron silicides discovered in Dhofar 280: hapkeite, fossilicite, and ferdi-silicite. Although they were all discovered to exist in this meteorite, the latter 2 had previously been discovered to exist naturally on Earth. They are indigenous to Russia, and so they did not get as much attention in the media. Hapkeite, on the other hand, has never been found to exist naturally on the Earth. Why exactly do scientists believe that hapkeite is a common mineral to the moon? Well, if we go to Anand's paper that the BBC article refers to,
physical and chemical reactions occurring as a result of the high-velocity impacts of meteorites and micrometeorites and of cosmic rays and solar wind particles are major causes of space weathering on airless planetary bodies, such as the Moon, Mercury, and asteroids. These weathering processes are responsible for the formation of their regolith and soil. We report here the natural occurrence of the mineral hapkeite, an Fe2Si phase, and other associated iron silicide phases in a regolith brecciaclast of a lunar highlands meteorite. These iron silicide phases are considered to be a direct product of impact-induced vapor phase deposition in the lunar soil, all part of space weathering. We have used an in situ synchrotron energy dispersive single crystal X-ray diffraction technique to confirm the crystal structure of hapkeite as similar to the structure of synthetic Fe2Si. This mineral, hapkeite, is named after Bruce Hapke of the University of Pittsburgh, who predicted the presence and importance of vapor-deposited coatings on lunar soil grains some 30 years ago. We propose that this mineral and other iron silicide phases are probably more common in the lunar regolith than previously thought, and are directly related to the formation of vapor-deposited nanophase elemental iron in the lunar soils.
in their paper, the team presented this little cartoon illustrating how they believe hapkeite and its iron silicide brothers were formed. Micrometeorites collide with the lunar surface. The hypervelocity impacts are so violent that they actually vaporize the silicon dioxides and ferrous oxides. Freed of their oxygen atoms, the iron and silicon atoms then condense to form these iron silicides, which then fall back down to the moon. Amazingly, Webb plays this cartoon at least 4 times in his series, and yet he fails to see how badly it hurts his case. The moon is rampantly hit by micrometeorites. Over millions if not billions of years, the uppermost layer of bedrock is pulverized to dust. If the numerous regolith samples are to be believed, there evidently must be a lot of dust up there, and therefore a lot of hapkeite formation. No wonder Aaron and his team concluded,
"We predict that the iron silicide phases are more prevalent in lunar soils than originally thought."
And yet, would you believe that none of the Apollo samples show this hapkeite that Aaron and team believe should be dime a dozen in the lunar soil? If hapkeite is such a common lunar mineral, why has it never been found in the Apollo rocks? I suspect NASA will suddenly claim to have found it in their rocks after this video is released.